Okay, example 1 says, is the given value a solution? So the value we're looking at is x equals 6. To test if it's a solution or not, we'll plug it into both of these x values. So 6 minus 1 less than 5. 6 minus 1 is 5. Is 5 less than 5? Since this is a no, I don't really have to move on and check the second piece because this is an AND problem. And an AND problem requires this value to work for both pieces. So the minute it doesn't work for one of them, my answer is no for the whole thing. Next one is an OR problem. And the question says, is x a solution to this compound inequality? So we're going to plug in the 3 into the x's. And in the first piece we get 9 less than negative 5, and that's a no. 9 is not less than negative 5, but since this is an OR problem, I have to go check the second one to see if maybe it works at least for that one, because remember the OR problem says either for this or this could be okay. So when I plug in 3 in the second one, I get 6 is greater or equal to 3, which is a yes. So since it worked for only one of them, my final answer is yes, it is a solution to this compound inequality. And has to qualify for both, or only one of them is sufficient. Next example, we got to do 4 things: solve it, graph it on the real line, give the solution in set notation, and also in interval notation. So let's go ahead and solve the inequality first. That's x is greater than 3, and subtract 3 from both sides, we get negative x is less than 7, and then remember dividing by a negative number requires you to flip the inequality. So it's this and that. Let's go ahead and graph it on the real line. So the first piece says x has to be greater than 3. I go to 3 and I shade everything to the right, and I have to use parentheses because it doesn't include the endpoint 3. The next one says x has to be greater than negative 7. So I go to negative 7, and since x is greater than negative 7, again I have to shade everything to the right, and since there's no equal sign, negative 7 is just the border, and I don't have to include it. Now remember, an AND problem says it has to work for both pieces, so I have to choose wherever it is that they overlap, which is right here. So the solution is what I'm showing in red. X is to the right of 3. That's the only place where they overlap. The other pieces don't qualify. So we did part A. Part B, let me show the graph. The final graph is really from 3 on is my solution because that's where they overlap. Part C, in set notation, well, it's x such that x has to be to the right of 3 or greater than 3. And then in interval notation, remember you walk left to right, and it's where you start and where you stop. We started at 3, and we keep going forever and ever to the right, so we go all the way to infinity. Okay, we're going to do the same 4 things here. First, we're going to solve the inequality. So that's negative 2x greater than 2, divide by negative 2, and x, we have to flip the inequality because we divided by negative 2 is less than negative 1. We do the same thing to this side, and we have 2x greater or equal to 8, and x is greater or equal to 4. So we've solved it. Now we're going to graph it. Remember, there's an OR in between them. So first piece says go to x equals negative 1 and make sure x is less than negative 1, not including negative 1 itself. So everything to the left of negative 1 and parentheses since it doesn't include negative 1. The next piece says go to x equal to 4, and x is greater than 4, so it's everything to the right of 4, and since there's an equal sign, it's inclusive with 4, so I put a bracket at 4. So since the problem is an or problem, the solution could be here or here. Both pieces are okay. So the final graph would be basically from 4 to the right and from -1 all the way to the left. That would be my final graph. In set notation, we would have x such that x is less than -1, so the first piece, or x is greater or equal to 4, which is the second piece. Then in interval notation, remember we walk left to right, so I'm coming from left all the way from -infinity, and my first stop is at -1, and then I pick up again union sign at 4 right here, including 4, so a bracket, comma, and I keep going to the right forever and ever, so I go all the way to infinity. Okay, we'll do the same ones for this 3-part inequality. I don't like those fractions, so I'm going to multiply everybody by the lowest common denominator, which is a 4 in this case. So these guys reduce and I get the 2 minus m in the middle. And then these guys reduce and I get a 2. These guys reduce and leave me a 2. 2 times -5 is -10. Get Vm by itself in the middle. That's going to be -12 is less than -m, less than or equal to, looks like we get a 0. Now divide by -1, and in the process, remember all the inequalities flip, and that gives me a positive 12. So since I'm used to writing in the order smaller to bigger number, I'm going to put the 0 on the left and the 12 on the right and preserve the inequality that my solution gave me. The mouth opens towards the 12 with this inequality, so I will do that. And the mouth here opens away from the 0 and towards the m, so I will make it open towards the m and away from 0. So these guys are exactly the same thing. I didn't do anything different. It's just easier on the eye to look at it from smaller to bigger number. Now graphing this, remember, is fairly easy. Say 12 is somewhere down here. M is trapped between 0 and 12, so I start at 0 and I go all the way to 12. At 0, there's an equal sign, it's included. 0 is part of my solution, so I use a bracket. At 12, I use parentheses, leave it open, because 12 is not part of my solution. In set notation, we've got x such that, or in this case, let's pay attention, it's actually m, and not the variable x. So m, such that, just copy your solution, m is trapped between 0 and 12. In interval notation, just look at your graph. You're walking left to right. The first time you hit the graph is at 0, comma, you keep going, and then you stop at 12. So the solution in graphically as set notation and interval notation is given. Okay, in this example it says the function f, shown in the figure right here, at the top of next column, I brought it next to it, so it's right next to it, gives the distance y in miles, so y equals f of x is the distance between a car and Omaha, Nebraska after x hours. So time goes by, and this is the distance between the car and Omaha, Nebraska, between 0 and 6 hours. Is the car moving towards or away from Omaha? Well, let's see. Initially, the car is 300 miles away from Omaha, and then let's look at 2 hours later, it's now 200 miles from Omaha. Then 3 hours later, it's 150 away from Omaha. 4 hours later, it's 100 miles from Omaha. So it looks like since the distance is decreasing, it's actually going towards Omaha. So we say it's going towards Omaha because as time goes by, the distance gets less and less. Determine the times when the car is 100 miles or 200 miles from Omaha. Well, when is the car 100 miles from Omaha? This is the distance. If I look at 100, it happens at the 4th hour. So at the 4th hour, it's 100 miles away from Omaha. Or when is it 200 miles from Omaha? Well, this is the distance 200, and that happens right here where the time corresponds to 2 hours. So at the second hour, we have the car for 200 miles from Omaha. So when is it 100 miles? At the fourth hour, or 4 hours later. When is it 200 miles away from Omaha? At the second hour, or 2 hours later. Next one is asking something a little bit different, slightly different. When is the car from 100 to 200 miles from Omaha? So it's not asking about the distinct 100 miles exactly when it happens. The distinct 200 miles exactly when it happens. It's from 100 to 200 miles. Well, from between, it looks like the second and the fourth hour, the car is 1 to 200 miles away from Omaha. In that range it happens. So we would say from 2 to 4 hours, basically between the second hour and the fourth hour, is when the car is between 100 to 200 miles away from Omaha. So part C is actually asking us for a range between 2 to 4 hours. So when x is between 2 to 4 hours. Yes, we could say when x is between 2 to 4 hours. And here we would say x is exactly at the fourth hour. And here we would say x is exactly at 2 hour mark. Part D, when is the car's distance from Omaha greater than or equal to 200 miles? Well, if we look at the graph, when is the car's distance from Omaha greater than or equal to 200 miles? Well, right here it's 200 miles from Omaha, and then it gets closer to Omaha. So if I look at this portion, that's when the car is 300 miles from Omaha, and then 250, and then 200. So in this time period, between the first 2 hours, we'll say during first 2 hours is when the car is 200 miles or greater away from Omaha. And we could, I guess, put that as an inequality. When time is between 0 and 2 hours, it's at greater than or equal to 200 miles, so we're going to include the second hour as well. So between 0 and 2 hours is when the car was 200 miles or greater than away from Omaha.